Vibe coding might work for a quick demo, but relying on unstructured trial and error will destroy any enterprise-scale AI architecture. Building large-scale LLM pipelines seems straightforward until you realize that the most critical bottleneck is context. Quality. If your RAG ingestion pipeline fails to deliver highly relevant data, the model degrades into hallucination or fails to respond at all.
Context you provide to the LLM matters a lot. Context in this case is the material you retrieve and augment your prompt with. If the context isn't highly relevant to the user's prompt or question, the LLM may generate a response that isn't relevant to the user's prompt or question.
And if there isn't enough context, the LLM may generate an incorrect response. It might hallucinate, or it may not generate a response at all. Because context is so critical to response quality, many advanced RAG techniques focus on improving the context included with the user's
passive context. Ingestion is a major system risk modern RAG architectures demand precise retrieval structures to prevent output degradation under heavy load. Many infrastructure engineers assume that dumping raw chunks into a vector database is enough for production search. At enterprise scale, the specificity fails without explicit metadata filtering. Similarly, queries get polluted with irrelevant context.
Data-driven filtering. Because at the end of the day, in the enterprise level, we will never be simply storing the chunks. We will be storing the chunks with the metadata. This is what I've seen many candidates miss. In the toy example that you might have seen, you might not use the metadata, but at the enterprise scenario, it's critical to have this metadata-driven filtering. Then what we have is the retrieval layer. Now, this is a layer where
simply relying on raw embeddings is a recipe for system latency and noisy retrievals. Real-world success requires active metadata classification, transitioning from deterministic, traditional back-end code to non-deterministic LLM output breaks standard, exception handling and orchestration pipelines. When your execution environment changes dynamically, standard testing assumptions fall apart.
The biggest part of it is the shift from determinism to non-determinism, and suddenly you're working in with an environment that's non-deterministic, which completely changes the FDA.
What is your understanding and take on vibe coding?
I think it's good for explorations, it's good for throwaways, disposable stuff, but you don't want to be using it for anything that's going to have any long-term capability. When you're using vibe coding, you're actually removing a very important part of something, which is the learning loop.
What are some either new workflows or new software engineering approaches that
if your production monitoring expects static outputs, you must redesign your error handling loops around non-deterministic runtime behaviors, scaling up automated evaluation using an LLM as a judge sounds elegant, but these architectures often harbor hidden systemic biases. The most notorious is positional bias, where the evaluator model consistently favors outputs in specific spots regardless of quality.
And this means that an LLM will continue to favor an output even if the content is not necessarily better. So let's say in the pairwise comparison case, you're asking the model, which is better, option A or option B? And it continuously favors option A, regardless of what is represented by option A. This means that it is expressing positional bias. There's also verbosity bias, and this happens when an evaluator continuously favors output that is longer, regardless.
Positional bias can quietly invalidate your entire evaluation dataset. Building robust validation pipelines requires running automated positional swaps during tests. In autonomous agent pipelines, simple reflex architectures process inputs immediately, but lack historical state mechanisms. Without tracking environmental evolution, they repeatedly execute identical errors under dynamic real-world conditions.
Simple reflex agents like this are effective in structured and predictable environments where the rules are well defined, but dynamic scenarios, they can trip these agents up, and because they don't store past information, they can repeatedly make the same mistakes if the predefined rules are insufficient for handling new situations. All right, well, how about this one? This is called a model-based.
Speed means nothing if the agent is blind to state history. True autonomous workflows require persistent memory layers to handle dynamic changes. Beyond position, automated evaluators consistently struggle with verbosity bias, equating sheer length of a generated response with high quality. This systematically downrates concise, highly accurate answers in favor of repetitive padding.
There's also verbosity bias, and this happens when an evaluator continuously favors output that is longer, regardless of its output. Again, the longer output can be repetitive or go off track, but the model will continuously favor it because it sees length as quality. This is verbosity bias. There's also the case where a model might favor an output because it recognizes that it created the output. This is called self-enhancement bias. So let's say you have a bunch of different outputs.
Redundant padding can easily trick your metrics. To combat verbosity bias, MLOps engineers must program rigid prompt rubrics that explicitly value brevity. MLOps teams often default to vector databases for all RAG architectures, ignoring classical relational models. When dealing with highly structured transcational data, standard semantic vector matching is actually highly inefficient.
Data. If the data you're using for context is structured, something like a relational database may be better suited for that than something like a vector database.
And you can also store the same data in different ways. For example, you can store data twice using 2 different chunk sizes and pull from both when generating the information to accompany the user's prompts to the LLM. And if you have data in multiple data stores, you can combine them at the retrieval stage of RAG.
I think we need another example.
Fair enough. If a customer's prompts was about, a delayed ship.
Vector storage is not a silver bullet. Hybrid architectures combining SQL databases with embedding layers provide the safest data fallback for production agents. When data pipelines ingest massive document sets, single static chunk sizes often miss local context. If a user queries delayed shipping patterns, pulling from static size definitions might omit critical transaction details stored in nearby schemas.
I give you a very simple example to start with, which is we have some interaction coming from the customer and we add some additional information, and then from here we can say, hey, there's this information available to you. And this is how we collect information. We have basically a REST server, which is called our collector. Then we persist the data into Kafka, from where we can.
A rigid ingestion pipeline is inherently flawed. You must mix varied chunk definitions to rebuild complete transcational state for your LLMs. Model drift is the ultimate silent killer of production text classification and then LP pipelines. When global events shift, semantic meaning, static pre-trained thresholds generate dramatically altered outputs without triggering system alerts.
So there's this thing called drift, where if a world event comes along and changes what the sentiment of a particular idea or topic would be, the model would perform differently. So you need to be constantly going back and reviewing it to make sure that the model is classifying what you want it to classify. So to wrap things up, let's revisit why text classification is so powerful. Businesses are getting...
Silent drift cannot be ignored. MLOps pipelines must incorporate continuous validation loops and systematic manual reviews to keep model classification relevant. Building a complex pipeline requires tight Alignment before writing code. Too often, MLOps tools expect you to show up with a raw prompt and compile a spec, assuming the system inherently understands your systemic dependencies.
Evolve, I've noticed three fundamental problems that most tools aren't addressing. And these are things that I try to solve as I iterate on Agent OS. And I'll show you how I use that to make my specs actually useful. So the first issue is a lack of process for establishing alignment. So most tools just expect you to show up with a prompt and generate a spec, as if they inherently know what you want and how that's supposed to fit in the bigger picture of your product. But we don't just wake up knowing what to build. Even
alignment is your first line out. Defense. Explicit strategic planning must precede any automated code generation. Block to ensure pipeline stability. When testing large AWS Lambda data pipelines, engineers often struggle to parallelize testing across isolated micro-functions. Pumping a single data packet forces you to traverse the entire architecture, completely hiding where local failures occur.
Is there an issue with this kind of testing? What are the difficulties? Yeah? Feedback. Yes. You don't get pointed feedback. The whole thing failed, but I don't know where it failed. Yeah, testing is difficult. The second thing is I want to test that particular Lambda, but I still have to run through the rest of it. So parallelizing the testing of all my Lambdas is going to be hard. What if
monolithic testing approaches yield slow, useless feedback? True reliability requires micro-unit testing to catch failures at the exact source. Moving from professional, spec-driven engineering to passive vibe coding causes immense unpredictability in LLM pipeline behavior. Relying on simple prompt trial and error lacks the structural testing needed for stable long-term deployments.
This is how professional builders move away from the unpredictability of vibe coding into a workflow that actually ships. It's a methodical approach that takes your product from idea to customer consistently. And for me, as a business owner and a product designer, it's what has me fired up about this moment. We're not just changing how we code, we're changing how we build. So a few months ago on this channel, I introduced spec-driven development along with Agent OS. That's my free open source system for powering a spec-driven process. And now we're seeing the big tool makers are converging.
Vibe coding is acceptable for quick prototypes, but scaling up an enterprise-grade AI engine demands deterministic spec-driven development in scale-up environments, executing system configurations manually using non-programmatic tools always invites human error. When configuring hundreds of servers, a single misclick can cascade into catastrophic system crashes.
When we click around, when we type around, usually new things that are going fast crash, right? So it's not the best of things you want there, right? You know, I think this is one of the first car accidents out there, right? So you can imagine about a situation where I had to do a bunch of disk mirroring on a bunch of servers out there with a bunch of clicks, and I had to do it in a relatively short amount of time.
Manual operational actions do not scale. Every pipeline component must be codified to ensure continuous, repeatable, and safe deployments. Performance tooling isn't just about shaving off milliseconds, it's about scaling infrastructure sustainably so. Database queries do not throttle parallel business activities. If scaling up, your pipeline crashes downstream systems, the architecture fails.
Danger is that A, it could fall over, or B, your costs can go up faster than your user base. So performance is not just about making things faster, but making sure you scale in a way that you don't slow down the rest of your business. So there's a kind of a bigger picture here, basically. So what the problem we want to try to solve here is if your minimal viable product gets really successful, how can you not slow down the rest of your business, basically? So
enterprise scalability requires proactive bottleneck identification to prevent resource starvation during sudden traffic spikes. Goal-based agents use internal models to simulate potential future states to make optimal decisions. However, if their simulation parameters do not align with physical realities, the predicted actions degrade rapidly.
So the agent uses its internal model, that's how the world evolves and what my actions do, to simulate future outcomes of possible actions, essentially predicting what will it be like if I do action A. Now that's a shift in decision making. The agent isn't just asking what action matches this condition, it's now asking what action will help me achieve my goal based on the current state and predicted future. So consider a self-driving car. If the goal is to get to destination X, it'll consider its state.
Simulation accuracy determines agent safety. Grounding internal predictive models in real-world telemetry is critical for autonomous decision-making when expanding generative workflows beyond specialized engineering departments. Token consumption can spike exponentially. This sudden sprawl across administrative and non-technical teams causes massive compute costs and resource bottlenecks. Clip file 16 MB for 00 seconds, 20 for 36 seconds.
So since January, I think our token consumption has gone up 86 times.
Wow.
So it's really, really quite incredible. We were not expecting usage to be the way that it has been, and it's been across the board. It's not just been in the tech and tech adjacent departments. We have seen people in finance, people in operations, people in the people team using agentic.
Spreading AI workflows creates massive scale-up costs. Implementation managers must enforce real-time API spending controls before widespread deployment. Running classification models on highly imbalanced datasets severely biases outputs against rare edge cases. If your training data does not cover the complete target spectrum, predictions will collapse in production.
The first one is what's termed as imbalanced data sets. So you need to make sure that you have the right number of examples for each type of thing that you're trying to classify. If you have too many of one type or too little of another, your output in your model won't be as balanced as you want it to be. So you need to make sure that you have the right number relative to the output that you're expecting.
Relying on generic, unbalanced training files ruins downstream classification, demanding rigorous hand labeling unvalidation strategies. Architecting an enterprise-grade RAG stack requires establishing a robust, multi-tiered pipeline starting at the knowledge layer. Simply storing raw X blocks skips critical preprocessing and chunking configurations.
When someone asks you as, design me a RAG pipeline, then in such scenario, you start with knowledge layer, then go to the retrieval layer, followed by the validation layer. So let me break this down. So if I want to start with this knowledge layer, this is where the knowledge of the enterprise lives. So here we will have the internal documents and the private data sources. This can be runbooks. This can be knowledge base. It can be compliance documents.
High retention pipelines must treat the knowledge layer as a structured data preparation engine, integrating metadata filters from day one, evaluating fluid, natural language outputs. Using rigid metrics like blue or rouge fails because they only analyze direct word overlap. Pipelines evaluating human-like outputs require a flexible, nuanced judge to assess stylistic quality.
Traditional metrics like Blue and Rouge focus on word overlap, which is nice if you have a reference, but what if you don't have a reference? What if you want to ask a question like, is my output natural? Does it sound human? LLM as a judge lets you do these evaluations on more subjective outputs without a reference. But of course, there are drawbacks to using LLM as a judge. Just like humans, LLM have their blind spots. And these are represented through different types of biases.
Evaluating subjective nuances requires an LLM as a judge system that can adapt rubrics as date of formats evolve, generating reliable contract tests for asynchronous data pipelines requires capturing interface behaviors accurately. Pumping dummy events through Kafka topics allows developers to validate if the outgoing schema conforms to structural specs.
Contract. So what I'm going to do is generate the test basis the spec. And what I mean by that is I will be pumping the message to the Lambda via the Kafka topic basis the async API specification. And on the return journey, I'll verify that the cancellation message which comes through is indeed according to the schema that's been set up in the async API specification, right? It's basically generating the test and validating whether the messages are going.
Automated validation. Using async API specifications ensures asynchronous Lambdas process inputs without silent message corruption, directly exposing internal database architectures to external clients is a critical failure pattern. High-performance microservice networks must interact solely through highly structured database with explicit access controls.
We don't just give everybody access to the database. We give specific things that the user can do. For example, we could get some data or we could delete some data. And these different things we can do, that concept is called an interface. And it allows us to interface with other applications. So we might have a different app over here. And we can interact with app 1 from app 2 because app 1 has an API. So these two apps could be two completely different apps. For example, I might be building some calendar app.
Building clear, isolated interface. Zones protects back end databases from resource exhaustion caused by unthrottled external requests. Enterprise RAG applications often make the error of storing raw embeddings without associated metadata. When a production query is executed, the absence of metadata filters forces the engine to run unguided semantic searches.
Drink. Then what we have is the retrieval layer. Now, this is a layer where we embed the query. We execute the semantic search. It is going to apply the security filters. In some cases, we might also apply the filtering that we would get from the incoming data. And based on that, we are going to retrieve only the relevant information. We call it as top K retrieval.
Under production loads, utilizing metadata-driven filtering is critical to isolate domain-specific queries and ensure fast, secure retrieval. Deploying AI systems without identifying their fundamental limitations is an incredibly dangerous operational strategy because non-deterministic models do not understand the why behind tasks. They fail to make balanced ethical decisions.
AI has a lot of limitations. We have to accept that. It still doesn't understand the why behind all the tasks we ask them to do. It needs human input for real-world context and scenarios. It may not work well prioritizing long-term business goals and assessing trade-offs. And last but not least, it's not reliable. It hallucinates and sometimes gives us the wrong answer.
Standard software tasks are easily democratized, but MLOps leaders must maintain strict human-in-the-loop oversight. For complex logical decisions, the paradigm shift from deterministic code, execution to non-deterministic, probabilistic AI outputs changes how engineers must design error recovery paths. Classic sequential error trapping is unable to process erratic conversational behaviors.
Comparable thing would be the shift from assembly language to the very first high-level languages. The biggest part of it is the shift from determinism to non-determinism. And suddenly you're working in with an environment that's non-deterministic, which completely changes FD.
What is your understanding and take on vibe coding?
I think it's good for explorations, it's good for throwaways, disposable stuff, but you don't want to be using it for anything that's going to have any long-term capability. When you're using vibe coding, you're actually removing a very important part of
transitioning away from assembly line determinism requires building highly adaptive validation and retry loops inside your pipeline, migrating raw customer transcational data from on-premises legacy databases to cloud environments often causes major pipeline bottlenecks if validation and parsing activities are not highly optimized. Downstream analysis systems stall.
And loading it into our ADLS location. And once this data is in ADLS location, then we perform different cleansing activities. And according to the business logic, we are finally loading the data into our gold layer. And then from that, our Power BI people or analyst can take away the data from there.
So what is your team size?
We are 7 people and others are tested.
2. Prevent data lake ingestion delays. Cleansing and business logic processing must be decoupled into staging zones before target delivery. Many pipelines implement ELT architectures to move transcational data into warehouse systems without tracing state changes over time. When source databases are constantly updated, static sync engines fail to capture critical intermediate records.
Again, an important point. Why we need ELT is because in order to identify the latest record, you have to store all the records at some place, because this is a transactional system. It will keep moving. Interesting for everyone. And in this video, we will understand some basic data pipeline design patterns. Following up from our previous video, which covered the basics of data pipeline, in this particular video, we will go a little deeper and try to understand.
Capturing transcational history demands change data to capture patterns rather than static batch extractions that miss runtime shifts. Upgrading massive stateful deployment nodes incrementally often leaves legacy artifacts that break production. Reliability. Real-world continuous delivery patterns must treat infrastructure as entirely immutable.
Using my install process. So I didn't have to have a separate process for upgrade. I didn't have to have a separate process for downgrade. Everything looked like an install. I just create a whole new machine from scratch, install into it, delete the old machine. And this is a big deal. Right? We can do I can do a massive upgrade from a system running on Red Hat to a system running on Debian with an entirely different file system, an entirely different version of my software stack. And it looks the same.
Using clean, spec-driven rebuilds rather than incremental system patching prevents state pollution across different operational versions. Relying on traditional batch data processing is fundamentally too slow for modern high-velocity microservices. When business ambitions require instantaneous reactions, pipelines must transition to real-time data streaming architectures.
We heard from Jay, who described how we've entered the streaming era because businesses need to work with their data in motion rather than just processing their data at rest, because that's just not fast enough. There's been some remarkable innovation in this space, and an entire ecosystem has sprouted up with what is needed to enable all businesses to become real-time. June described to us how Kafka has become the center of the streaming ecosystem. It's growing at an incredibly massive rate. We also see that
set your data in motion through a continuous, real-time streaming nervous system to prevent downstream analytical bottlenecks. In high-velocity DevOps, pipelines integrating complex security and compliance checks late in the deployment cycle consistently triggers release delays. When security is treated as an afterthought, vulnerabilities slip directly into production.
So how do you include security and compliance without being a blocker and affecting release dates? So obviously we all know about the concept of shifting left. So security, we all know, has to shift left. But the question is, how do you do it? Security starts from planning. You embed your security experts as part of your Scrum team. So now when you're planning, when you do your estimates, you're not just estimating, oh, this is how long it's going to take me to write my code, and this is how
Shifting security left, embedding compliance validation directly into early pipeline planning stages is critical to maintain rapid release velocities. Building a complex deployment pipeline without clear architectural abstractions results in highly cohesive but completely unmanaged systems. If your orchestrator and build agents are tightly coupled, the pipeline becomes brittle.
We care for as engineers, as engineering managers, as architects, as the C-suite, your product officer, your information officer, everybody cares for these milestones, like how you're doing it. These are events that the domain experts care for. So I'm just going to imagine myself as the expert. So if how the pipeline is progressing is something that I definitely care about. Ubiquitous language is shared language. This brings all the teams together. So how many times have I sat through meetings where I
Utilizing decouplet aggregates and clear abstract models ensures different deployment stages scale independently without corrupting structural state. Strong boundaries preserve pipeline integrity. Decoupling your aggregates is the only way to scale dynamic environments safely.